Well, hello and welcome to the Smells Like Money podcast. Join me, Suzanne Chin Taylor, the DooDoo Diva, as I interview guests who are making an impact on how we manage and operate systems for conveying and treating wastewater. As a veteran of the wastewater, trenchless, and civil infrastructure industry, each week I'll be bringing you industry know-how from industry pros who know how. Join me each week as I speak with representatives of organizations that are utilizing disruptive or new technologies and methods, and executives who are excited to share how to be successful and sustainable in our vital industry. So whether you want to learn about the latest trends in technology, in treatment or trenchless, gain tips on training and retaining great talent, or simply how to be more efficient, productive, or profitable, this podcast is for you. Ready? Let's dive right in. Well, hello, everyone, and welcome to this week's episode of the DooDoo Divas Smells Like Money podcast. I am here today visiting with Bob Berger, the owner and founder of NanoWorxs. Welcome to the show, Bob.
Hi there. Good to see you. I'm glad to have a meeting here.
So, Bob, what is up with nanobubbles?
Well, if anyone's seen the short slide presentation on LinkedIn, they probably have a preview. But nanobubbles, very little is up because they aren't buoyant and they don't float easily. So that's why that's really why the title came about. So that's one of the secrets to nanobubbles is that unlike conventional bubbles in any aeration system, they don't float to the surface and pop and lose most of their gas. So we've found that nanobubbles with most types of gases, usually oxygen, will float in solution for weeks, possibly months, all the time releasing oxygen into the water. So that's the biggest.
We hear a lot of things about it. I mean, it's not that it's brand new. It's been around for a while, but there's been a lot of buzz about it. A lot of people saying, benefits, pros, cons. So all of the things that we're hearing about this as it's related to, because the show is about wastewater, but, municipal wastewater and process wastewater, industrial wastewater. Myth, fact, fiction, what is it?
Oh, it's definitely fact. I've been working with nanobubbles now for about 5 or 6 years, starting with another manufacturer that wanted me to sell and provide applications. So I'm now working with another company, Tech, based in Chile, that actually has designed and manufactures the nanobubble systems that I sell and work with. But the real secret to nanobubbles is that they are completely different than conventional aeration, conventional bubbles. Like I said, most bubbles, you discharge them at the bottom of a tank and they quickly rise to the surface, giving off some of their oxygen to create the aeration. With nanobubbles, you don't have to run them through a diffuser. You basically just dump them out of the end of a pipe with a liquid pump, and the nanobubbles are already in the water. So all you're doing is recirculating the wastewater with nanobubbles in it. The nanobubbles, number one, give off oxygen as they move around in the water, and that obviously creates increased oxygen in your aeration tank, for example. But the other secret to nanobubbles is that when they finally collapse and give off the last of their oxygen, they create a quick burst of energy, and it creates oxidizable material called reactive oxygen species, things like hydrogen peroxide, superoxide, and hydroxyl radicals. So anyone that's working in the wastewater field realizes that this is a great in situ treatment that you didn't have before. Traditional aeration doesn't do that. It just provides oxygen for the microbes, which will degrade the material.
So from what I understand, this is not meant to be a replacement for your traditional aeration. It's meant to be an adjunct or a bolt-on to make it more efficient.
It can be either.
Okay.
We could easily add nanobubbles to a conventional aeration system, but the nanobubbles in that case would really be in place to oxidize the organics and reduce the sludge volume and increase the efficiency of the treatment process.
So can this technology, is this something that has to be thought about before, like at a design build or when there's going to be an upgrade? Or is it something that can be easily and readily retrofitted into an existing plant with what they have and play nice?
Both.
Okay.
What we're finding is that we could go into an existing plant. Maybe they're finding in the summer when the temperature goes up, they're short of aeration capacity, and rather than putting in larger blowers or a new aeration system, we can add nanobubble oxygen. Which another interesting fact is that the nanobubbles are not affected by temperature and pressure. So normally, oxygen in water, as the water gets warmer, it evaporates or basically diffuses to the air. So the warmer the temperature, the lower your oxygen, and you end up real problem. If you've got nanobubbles in the water, it's not the oxygen inside the nanobubbles themselves until it's released is not affected by temperature or pressure or even salinity to any great degree. So it's really kind of a built-in backlog of oxygen. So come a real hot weather spike, you can still coast through that process when you have nanobubbles.
So why nanobubbles over other, technology that's been around that we're used to? Sometimes, we've had this conversation offline that often, utilities they're a little risk adverse, whereas industrial, treatment, because this is going to affect the bottom line and profit, they're a little more open to putting this in place. So maybe let's talk about the experience. So the way, I'm hoping maybe we can dispel the fear for wastewater folks who might be tuning in. What have been some of your experiences incorporating this on an industrial side that have been beneficial and not disruptive to what they had already, but actually beneficial in making what they already have more efficient or cost effective to run?
Yeah, and the tough part is understanding the science of nanobubbles are so different than the conventional aeration, conventional bubbling process. So that's usually my educational thrust, is to really introduce and walk the client through what they are, what they can do, and really at the end of the day, what's the benefit to putting the system in. So I think people are finding that the nanobubble oxygen in particular is doing a good job on surfactant removal. We're finding that fats, oils, and greases at the pre-treatment stage can be enhanced by the use of extra oxygen. Septic, fats, oil, and greases, and then even adding it throughout the plant. We're putting a process flow diagram together as we speak, trying to convince folks that adding nanobubbles even at the primary clarifier stage before you get to aeration enhances the reduction in organics. So really, as you go through the whole plant and we're starting to look at all the process dynamics, we're seeing significant savings. If you have an existing plant, we're not going to downsize tanks, obviously, but we can increase the effectiveness and the efficiency. If you're in the planning stage for a new system, we may be able to decrease the size of your facility by the use of nanobubbles because they're so much more effective. So an example I throw out is that in a typical aeration basin, you're maybe getting 8 or 10 parts per million on your best day. If we're adding nanobubbles, we possibly could get that up to 70 parts per million. So it's a pretty dramatic increase, and the more parts per million you've got means the more oxygen you have, and the more oxygen you have, the better the microbes are growing and multiplying, which is reducing your organic load. Plus, it's got that oxidizing effect when the bubble collapses to also oxidize the organics. So there's a multitude of benefits, and they all act upon each other.
Well, when we think about this technology, whether from yours or, any other manufacturers doing nanotechnology, if somebody's thinking about it, how about the cost for operation? There's a lot of folks were thinking about, oh, we need to go natural. We need to go more sustainable. We need to be environmentally friendly, get away from the chemicals. But now what about the power consumption needed to generate these bubbles? And what does that look like? And if you're putting it on, everybody knows when it comes to aeration, that's probably one of the largest consumers of electrical
Absolutely.
power in any treatment plant. Does that offset that? Can that help with energy consumption and bottom line savings?
All of the above. I mean, we're definitely very green because we don't use any chemicals. So nanobubbles are generated in my system by pressurization and depressurization of water moving through an injector, which is basically just a piece of pipe with some very specially designed interior compartments, if you will. So it basically pressurizes the water and then quickly depressurizes as you're adding oxygen as a gas. There's no moving parts and there's no power. So it's basically a piece of pipe that you're pushing water through, and it's creating the nanobubble inside. So
how does that, wait a minute, how does that work without power?
Well, we have to use a water pump or a liquid pump.
Oh, okay.
So that's the only power. So the power we need is probably what you're already using on a plant. If you've got a pump that you're recirculating instead of using gravity, we're using that pump, and we just need to match it with the flow rate and the amount of oxygen we can inject. So the only other component would be an oxygen concentrator. So rather than using a tank oxygen or using ambient air, which is only 21% oxygen, we like to use an oxygen concentrator, which basically pulls air, removes the nitrogen, concentrates the oxygen, and then sends it over to our injector, which ends up at about 92% oxygen being injected. So that does consume some electricity, but it's really very low. So the economics that we're looking at are awfully good, and we're not using any chemicals. All we're using is oxygen.
Can this be used in a decentralized facility as well as a standard centralized facility?
Yes, we're looking at using nanobubbles in small to medium-sized package plants that could easily be transported, dropped into place, and basically turned on, and you've got some treatment. So it's certainly, the nanobubbles, what we're finding is it certainly saves on size. I mean, we've been talking to folks that make dissolved air flotation tanks, and we can reduce the size of that tank, which means you can start to shrink your package, which is always beneficial.
Okay. I'm looking at your little presentation, your little cheat sheet here, and I love this. Explain what is meant by and why it does this. Nanobubbles are generated in a range of bubble diameters. And, there's obviously a reason behind this, the science of why it would want to be done that way. Because people may ask, well, why do you do that?
Well, we don't actually purposely generate specific diameters. What we find is, and I think this is one of the sciences that's evolving, is that our generator basically produces nanobubbles in the range of 10 or 15 nanometers up to about 300 nanometers. And even at 300 nanometers, if I held a glass of water up and said, this is full of nanobubbles, you tell me I'm crazy because you can't see anything. They're not visible to the naked eye. They're basically in the range that we're generating them. They're the same size as red blood cells, viruses, and bacteria. So
you can only see them with a microscope.
You can see them with a good microscope, and there is some equipment out there called NanoSight and NanoSizer that companies can actually generate a volume and give you a bubble diameter. So those are kind of the gold standard right now for what size bubbles are we producing and how many. My equipment, the equipment that I'm using, is generating 200 to 300 million nanobubbles per milliliter of water.
So what does that mean to the treatment plant?
It just means a gazillion bubbles.
A gazillion. Well, here's what's the difference? And it says, will take 6 to 7 seconds to reach the surface at a 4-foot depth. A
microbubble. So a microbubble is what you would probably find out of a fine diffuser in an aeration basin.
Okay.
So if you push air or even oxygen from a blower and into your fine diffuser. As it comes out of the diffuser, it wants to immediately move to the surface. So takes basically 7 seconds to go from the diffuser to the surface. And during that transport to the surface, it's giving up some of its oxygen. But it's, even the best in diffuser systems are probably 50% transfer. The rest of it is lost when it breaks at the surface. The bubble breaks at the surface. So what we would do,
the advantage of the nano is that you don't have that loss.
Exactly. And the nano bubbles stick around for weeks, days at least, in even wastewater treatment. So we always have a reserve of oxygen, if you will. So I've been to a plant where, if their plant aeration system goes down, within a couple of days, their plant goes anaerobic and they've got real problems. If your nano bubble pump went down, my guess is, based on the data I've seen, is that we can continue to operate for maybe a day or two before it gets a crisis stage.
I want to go back on that, go down that rabbit hole there. You were saying about if a plant goes down, like the aeration goes down, you're going to go, would you say, anaerobic, and you're going to have a whole host of problems, compliance, getting it back in. If a nanobubble unit was attached to that, and the aeration, would that help for it to not go into that danger zone, or be able for it to recover more quickly once it's back online?
Yes, because we're, for every pound of oxygen we're putting into the water, 95% of it is actually going into the water, unlike conventional bubbles where you're losing 50%. So nanobubbles are much more efficient at transferring oxygen into water, or other gases as well.
So it could almost be used, I don't know if this would be, cost effective to do it, but it could almost be like a fail safe in the event of, power out. Does it run on, can it run off of solar or any other type of, like a backup generator? Typically,
if we could run the water pump, if depending on the size of the plant and how much water you're pumping, if the water pump can run on solar, then we're other than the oxygen concentrator. But in a backup situation, you could actually have a tank of industrial grade oxygen just sitting there, and if you needed it, you turn it on, and as long as you got a pump that's moving water, we're producing nanobubbles. So in a backup mode, it may be a good tool. We just have to design to make sure that we can produce enough oxygen to keep the system alive until your aeration basin comes back on.
Now, maybe you don't know the answer to this, but I'm going to ask it just because it's a big hot topic right now. Can nanobubble address some of these, emerging contaminants that we are dealing with, like PFAS and other, things that are coming into the plant that we've never been designed to deal with this? I don't know if it's proven, but can it help?
I'm glad you asked. We are working with some engineering consultants right now to match up probably nanobubble oxygen with maybe a metallic catalyst along with some other. It's not going to destroy PFAS by itself. I'm certain of that. But I see enough opportunities, and we're exploring a number of them. Things like pesticides, bacteria. We can add ozone nanobubbles at the end of a treatment plant and do as good a job as the existing chlorine system. Whether we can get that past all the government regulations, we'll see. But I'm confident, based on the data I've seen, that ozone nanobubbles in conjunction with possibly electrolyzed water will do a lot less hazardous than adding chlorine.
Oh, wow.
So there's another piece. There's
hope. So there's hope there. There are some now emerging technologies to deal with this. I mean, with that new legislation coming down, we've got to move fast. What about things like microplastics?
I just had somebody ask me that based on my my LinkedIn article, and we're actually doing some testing with a university right now. We already have data that shows that nanobubbles does an excellent job of floating very small particles and very low density particles. Working in the mining industry, for example, that's real important to them. So I think there's an excellent chance that we could use nanobubbles to froth flotation, which is a process to remove all those really small particles, because nanobubbles do a real nice job of connecting to little particles that traditional bubbles don't.
Ooh,
So
interesting.
I think there's real promise. Like everything, we've got to take it down the road and improve it.
Right, right. Well, that's definitely going to be something to watch with this technology, because these are two really big problems facing us right now that we've got to find a solution for, and quick. So, Bob, I want to thank you for coming on the show and, kind of giving us a lesson of, what we call nanobubbles 101, that
There you
it
go.
isn't this, woo-woo science out there. It actually is, it is real.
It is
And
real.
it solves some really big problems. And so any of our listeners who are interested in learning more about nanobubble technology, reach out to Bob. You can find him on LinkedIn. His information will be in the show notes below, but you can check out his technology at NanoWorxs, which is NanoWorx.com. And again, thank you for being on the show, Bob.
Sure.
And to the rest of you, till next time, keep it flowing.
Thank you.
Thanks so much for joining me, the DooDoo Diva, on this week's episode of Smells Like Money. What stood out to you this week? Share your takeaways by leaving me a review. You can find out more about the new technologies, creating sustainable solutions, and insights on how to succeed in our vital industry by subscribing to the show. Whether you want to learn about the latest trends in wastewater infrastructure, treatment, or trenchless, you've got it all right here at Smells Like Money. If you're an industry expert and would like to be considered as a guest for the show, book a quick chat with me by visiting calendly.com/the2it group /B-A-podcast-guest, or simply click the link in the show notes below. Until next week, a big shout out to all my industry friends and those who will be. You are my superheroes. Thanks for tuning in, keeping it flowing, and we'll see you all next week.